Hey everyone, welcome to A Builder's Guide to Testing. I am Bikram Bora. I'm a Solutions Architect at Amazon Web Services. In this session, what we'll be looking at is how to leverage the power of testing to build more resilient, cost-effective, and scalable software. So let's dive right into it. We'll look at this from the perspective of the journey of a line of code, how it starts off in a developer's laptop straight through to production. We start off with the local dev and test environment. In the local dev and test environment, we write code iteratively, debug, and test. The faster the feedback loop in this section, the faster developers can get error-free features out to the hands of customers. The next step is integration. In this step, what we look at is how does our code or feature perform against other developers' code. This is ensuring that we don't break somebody else's features and how well it performs in the overall code base and other services that it integrates with. This can happen in a local premises server or in the cloud. The final step is getting the code out into deployment, and this is where you would either push it to production or if it's a mobile app, get it out into the hands of customers. In this step, we still keep monitoring the app constantly. What you'll notice is that I've left out testing from the overall journey. That's because testing is implicitly built in every single stage. The more testing we can do, then the more feedback we can get real time, the more robust our software and will improve the quality of our code. Okay, let's dive right into the first section, which is local dev and test. If you're doing local dev and test today in AWS, most customers are using a varied set of tools. So developers are using different IDEs, toolkits, and SDKs. For in the AWS world, if you're using AWS Cloud 9, that's a first-party IDE that we have, which is cloud-based, and you can use our native tools to build against it. You can also use the Eclipse as the IDE, or you can use the AWS command line tools. If you're more of a Visual Studio person, we support Visual Studio and VS Code. If you're in the IntelliJ suite, you can use IntelliJ or PyCharm. Or if you're an Android or iOS developer, we have Amplify for Android and iOS. So as you can see, we continue to support a varied set of developer toolsets, and we will continue our investment in this regard. If you're using AWS, you probably have heard of AWS CloudFormation. That's how you do infrastructure as code, and you can script your entire backend infrastructure. On top of CloudFormation, we've built toolsets such as AWS Amplify and AWS SAM, which help make it easier for developers to build common constructs. So as an example, if you wanted to emulate AWS Lambda locally, these are the tools that you'll be using. Developers often ask me, hey, how can I replicate the cloud services that I'm using locally so that I can increase my feedback loop's speed? Well, that's done through tools like AWS Amplify and AWS SAM. Let's look at which services you can emulate locally. If you're using AWS, and if you want to replicate our endpoint services, you can replicate our HTTP endpoints, REST endpoints, or GraphQL endpoints. So you can replicate AWS API Gateway and AWS AppSync. You can also emulate AWS Lambda, which is a compute and function as a service. You can replicate AWS Step Function, AWS DynamoDB. And if you're using our developer suite of code tools, you can replicate Cloud9, Code Build, or Code Deploy. And then after you've templatized these services, ensured they're working fine locally, you can deploy them in the cloud with the certainty that they'll perform identically. This ability to bring the cloud services down to your local laptop and then dev and test locally and then push it back to the cloud is really powerful in increasing the speed of developers. Let's look at an example where me as a developer have written a line of code. It can be either a bug fix or a feature branch. So in this case, I'm using the feature branch Git flow, and I've made a few commits. So I've made a branch from master, made a few commits, and about to raise a pull request back into master. In this example, when I raise a pull request, the usual flow that happens is then another developer reviews my code, provides me feedback. What this means is that I have to wait for another developer's time, so when they're available. And also what we often find is that in code reviews, developers tend to focus more on business logic rather than the code inefficiencies. And this is a place where I'm about to introduce a service called Amazon Code Guru Reviewer. Code Guru Reviewer integrates with your Git workflow. After you connect a repository, either a Git repository or a code commit repository, on every pull request, it will read your code and provide you intelligent recommendations of code inefficiencies that you can rectify before another person reviews it. As I said, Code Guru integrates with two styles of Git repositories, so GitHub and code commit. After you've associated your repositories, it triggers on every pull request. So let's jump right into an Amazon Code Guru Reviewer demo. All right, let's get started with the Amazon Code Guru Reviewer demo. Here I am in the Amazon Code Guru Reviewer dashboard. On the left, I just go into Associated Repositories. I click on Associate Repositories on the top right. As you can see, the source providers are GitHub and AWS Code Commit. If I use Code Commit, I have to authenticate via an IAM role, and if I'm using GitHub, then I authenticate via username and password, the usual OAuth flow. So I hit Connect to GitHub. Now I've signed into GitHub previously on this computer, so it'll use my OAuth credentials to connect me to GitHub. Now, since we're connected to GitHub, what you'll see is all of my GitHub repositories become available here. So I can just pick one of them and click Associate. Now my GitHub repo is in a state of associating. Once this has completed, what Code Guru will start doing is monitor any pull requests that I raise. As soon as I raise a pull request on my repo, it will go through that code in that pull request and provide me intelligent recommendations. As you can see here, I've already associated a repo called Code Guru Java Test. Let's check out what's in that repo. So here is my empty GitHub repo called Code Guru Java Test. There's no code inside it besides a README. Now what I've done is gone through this Java Design Patterns repo, and I've downloaded all of this code. And then in my Code Guru Java Test, I've uploaded all of it into a branch called Feature Branch. So here you go, all of the code is in here. So what I'll do now is raise a pull request from my feature branch, which has got all the code in it, to my master, which is currently completely empty. And that means that the pull request will contain all of this code. And as soon as the pull request is raised, that means that Code Guru will then read through all of that code and provide me recommendations. So I go in pull request and I raise a pull request. Now, here what you'll observe is I've already raised a pull request. This is a pull request from the feature branch to master. In here, what you'll observe is in line, Code Guru has automatically generated comments. So Amazon Code Guru Reviewer has given me comments based on which section of the file it's referring to. So in here, what you can see is there's a memory leak, and it's telling me which particular class that memory leak is being caused by. If we go down, it's recommending me use a different date format class. If we go down even further, there's other recommendations. So it's got a thread safety issue based on concurrent hash map. It's recommending me to use a different class. So what you'll observe here is that all of these code inefficiencies I can rectify before a human ever looks at that code. That means that all of my real developers can focus on the business logic and getting features out to customers instead of focusing on what my code inefficiencies are. The best part about Code Guru is after you've associated the repo with the Code Guru service, you never have to log into AWS again. Your developer workflow doesn't change. It's already embedded into their existing developer workflow. All right, that's it for the Code Guru Reviewer demo. Let's get back into the presentation. Okay, having seen the Amazon Code Guru Reviewer demo, let's move on. So now that our code review has been accepted, we've merged into our feature branch into master. At this stage, the integration and test workflow kicks off. So let's dive into that. In the integration and test stage, as I mentioned before, we'll be reviewing how our code performs against other developers' code. So in this stage, we have the source control management system kicks in, then we build and test our code, and finally we deploy our code. In the AWS world, you'll be using something called AWS Code Commit, AWS Code Build, and Code Deploy to finally get your code out the door. These are encapsulated within a service called AWS Code Pipeline. If you're using some third-party service or a service built by our partners today already, you can use any of those interchangeably and put those into the appropriate slot. For the purposes of this session, let's look into AWS Code Build in detail. So starting off with AWS Code Build, how we control Code Build and how we give it instructions is through a buildspec.yaml file. The beauty of this is that this is also checked into source control. Every time there's a pull request that's been merged, or depending on how you want to trigger a build, it will give you a fresh Dockerized environment that you can download all of your dependencies and build a fresh version of your package. That means that there's no dependency mutation or there's nothing else that can interfere with how your build performs. Looking at the details of what's inside a buildspec.yaml file, first we have environment variables. So these are all the variables that need to be injected. You can think of these as passwords, parameters. At this stage, Code Build can actually reach out to services such as Secrets Manager and Parameter Store to fetch encrypted passwords, so you don't have to put them in clear text in your code. In the next stage, that's where you configure the install, pre-build, build, and post-build phases. After you've installed and built the binary, in the post-build stage, you can hook into any testing suite that you want to use to test your code. In the next stage is where you have reports. So in this stage, the outputs of your build and your tests are published into things like an S3 bucket, or you can push it to CloudWatch logs. In the final stage, you specify which artifacts of your build you want to preserve. So that can be the build binary itself and any reports, and these are published to an S3 bucket. So overall, that's the workflow. Code Build downloads the source code into a fresh containerized environment, builds the managed code in a containerized environment, runs the testing suite. This can be any testing suite that you specify, streams the log to CloudWatch, and finally publishes the artifacts in Amazon S3. All right, let's look at an example of a customer that's worked with us to really improve the speed at which they do integration testing. The customer here is called Blackboard LMS. They're a quite popular learning management software provider. And what they had as a problem was their integration suite took about 4 hours to run. What this meant is during a 24-hour day, they could only have around 6 builds complete, which was a significant slowdown in developer velocity. So they came to us with that problem and they tried different approaches. In their case, they were using the Selenium UI suite. That is a very common web developer UI testing suite that's in use today in the market. And their primary objective was to reduce test time. The solution that they came up with was quite innovative. Let's look at that architecture in detail. So here we have a test runner that's running on an EC2 machine. The test runner actually reaches out to Lambda. Within AWS Lambda, they're running the full version of Chromium. And in there, they have simulated virtual display units. So Lambda's simulating out frames to the simulated virtual display unit. They're taking screenshots from that. So that's where the UI test screenshots are getting recorded. And then all of these are published to an S3 bucket. Once in the S3 bucket, another test collator collates all of this data and puts it into a nice dashboard that can be viewed later. So what you've seen here is that depending on how you want to structure your testing suite, you can scale it out to infinite amount of nodes if you're able to run it on something serverless like AWS Lambda or AWS Fargate. The outcome of this was that their total integration time went down from 4 hours to 3 minutes, which means they were able to do multiple hundreds of builds and integrations a day. And that meant that developers could ultimately get features and bug fixes out to customers faster. All right, having discussed local dev and test and integration, let's jump into the deploy and test section. There's multiple ways to test code that's already in production, that has been deployed. And there's multiple topics which have been covered in detail. So performance and load testing, canary deployments, A/B testing, monitoring and optimization. A/B testing and canary deployments have been talked about in great detail in other reInvent and AWS Summit talks. So today we'll be focusing on performance and load testing and monitoring and optimization. If you're getting started in the load testing environment, you've probably come across a tool called locust.io. there's a managed marketplace, AMI, available in the AWS Marketplace. It has a nice GUI that you can interact with, and you can pick an endpoint. This can be any endpoint which is reachable over the network, and it hits that endpoint with amount of load. If you're a bit more mature in your load testing journey, you've probably come across something called a Apache JMeter. And finally, for the seasoned veterans, you're probably using something like Taurus, which is an integration of JMeter and Selenium that has a nice GUI built on top of it. But quite often, the feedback that customers and developers give us is that it's not the load testing tool itself that's the main issue. It's how do you scale out your load testing framework to a point where you can simulate an actual traffic day. So let's say you wanted to simulate a fire sale day or something like where you're having a big event with a lot of traffic. You want your load testing infrastructure to scale to that point. So let's look at an architecture which does exactly this. So here we have an AWS environment, and we're loading, in this case, the Taurus Docker image onto an Elastic Container Repository in ACR repo. In our test runner framework, we have an AWS Lambda function that's orchestrating the whole thing. It's pulling out jobs from an SQS queue and writing the information back to Amazon S3 and DynamoDB. The actual test is run in Fargate, which is a serverless container running mechanism. That means that you just specify how many containers you want, and Fargate will deliver them for you. In a short while, we will look at this demo in production and how it's actually performing and how a load test can be performed. Okay, once you've done a load testing, that'll help you identify the bottlenecks of where your software can potentially break. But what about code bases you've inherited? Or what about code bases that are already in production and you want to know where the performance inefficiencies are? Well, that's where Amazon Code Guru Profiler comes in. So Amazon Code Guru Profiler is a library that you integrate with your code, and that sends up performance metrics up to the cloud. That helps you really review how your application is performing in production. All right, now let's dive into a demo of the distributed load testing framework and Amazon Code Guru Profiler. All right, let's get started with the demo. As you can see here, there's the overview of the architecture of the solution. There's a source code and CloudFormation template if you want to have a look at it. I'll just go in straight ahead and launch it in my AWS console. This will take me to the CloudFormation wizard, and if I fill in the steps, that'll go ahead and deploy the solution for me. As I mentioned before, this is a completely serverless solution, so it'll only cost you money when you're actively running a load test. For now, let's go into one of the solutions that I've already deployed in my account. So this is what the output looks like once the CloudFormation has finished running. As you can see, I've already run a few load tests before, but let's go ahead and create a new test. I go into create new test, I give it a name, a description. So in this case, we're testing an API gateway endpoint, a task count. So this is the number of Fargate tasks or number of Docker containers that you want to launch. For me, I'm happy with 10. Concurrency, so how many concurrent requests are generated per task. For me, I'll put in 20. Ramp up. So this is really helpful in testing out architectures which slowly scale or are scaling organically. So let's say if you want to simulate how effective your cache is at hydrating, how effective your load balances are, or auto-scaling. This is really intended for that purpose. So I'm going to give it a ramp up of 1 minute, and I'm going to hold my maximum load for about 2 minutes. That means my total test time is going to be a total of 3 minutes. You can put in any HTTP endpoint that you have to test, that you want to test. For me, I'll just put in an API gateway endpoint. We'll touch back shortly in how I got this endpoint. You can test get methods, put, post, delete out of the box. You can put in your HTTP headers and the JSON payload that you're expecting. And then you just hit submit. Let's go into test 6 and see what the overview is. So you can see the test is now in a status of running. What this will do is this will slowly provision my tasks, then they'll go into pending, and then eventually they'll be running. And that's when my containers will ramp up. So if I refresh, as you can see, some of the tasks are already in provisioning, some are in pending, and eventually they'll all be running. While we're waiting for this to ramp up, let's look at the endpoint, the API gateway endpoint that I'll be actually testing. So here I am in my AWS console. I go to API gateway. I've provisioned a simple API gateway and REST endpoint, which is backed by an AWS Lambda function. So I've called it Hello World. Let's look at the interiors of what that method has. So it's got a method request, then goes out into an integration request. So that's executing a Lambda function, comes back with a response from Lambda and sends that response back out. We can also have a look at the Lambda function that's sitting behind this. So as you can see, it's being triggered by API gateway. And if we scroll down into the code, all it has is returning a status code of 200 and a message saying hello world. So quite a simple Lambda function. Now if we go into API gateway and go into stages, if you look at the production stage, so that's the invoke URL that I had pasted into my load test earlier. So just to test this out, let's paste this into a browser window and go hello. That's the path that I'm testing. As you can see, it's responded back with the hello world message. So that's the endpoint that's being tested. Now let's go back in and check how my load test is doing. If I refresh, as you can see, 6 containers have already started up and 4 are in pending. I can also view the same status in the ECS console. As you can see in the ECS console here, all 10 of my tasks are now running, which means that I've completed the ramp-up period and my API gateway endpoint is being hit with all of that load. Now the easiest way to visualize this is actually going into the Lambda function and seeing how many invocations it's doing. So let's go into monitoring. And I'll give it a sec for the CloudWatch metrics to come up. And if I push my window to 45 minutes, so traffic hasn't yet started ramping up to my load test. Let's give it a bit of time for my load test to complete. And in that time, we'll jump in and give you a preview of what the Amazon Code Guru profiler looks like. So in services, we go Code Guru. All right, here we are in the Amazon Code Guru profiler dashboard. Let's go into profiling groups. As you can see, I've got a few demos here. Now let's create a profiling group. I'll call this my new profile. I go create profile. What that'll now do is show me the instructions of how to integrate this into my code. So it's given me the output of the IAM roles that my agent will use. It's also given me for Java applications how to dependency map this. So if you're using Maven or Gradle as a dependency manager, just paste this into your Maven or Gradle repo and it'll pull the appropriate dependencies. And finally, it's given me the import statement and what the statement is to start the profiler, right? So that's all it really takes to integrate the profiler into my code base. Now, once integrated, let's look at an example output. So this is a Code Guru example output with issues. So this is what the output looks like. As you can see, it's giving me a proper stack trace. It's giving me functions that are being called. And I can observe that it's really inefficient in certain places, right? So there's quite deep stack traces. So for rectification, I can look at the recommendations on the top right corner. So Code Guru has, based on my profiler and based on observing my stack trace, made a few recommendations. In this case, it's recommending the AWS SDK clients being created multiple times. So it's saying that I'm wasting memory by recreating these objects, and I'm better off by using a singleton or a global class. I'm doing excessive debug and trace logging. So this is another recommendation that Code Guru is giving me. Instead, I can reduce the amount of trace logging that I'm doing. But you'll notice it's also giving me a percentage of the time that the CPU is spending on this particular task. Recreation of loggers. So here Code Guru is pointing out to me that I have created objects again which are unnecessary, and it's better off using a singleton class or a global one. As you can see here, it's giving me very specific code changes that I can make to reduce the infrastructure cost of running the application. And that means that I can potentially scale out my application whilst reducing the amount of underlying infrastructure that reduces. For applications which you're written yourself, this is effective, but imagine for applications which you've inherited and need to identify the inefficiencies in. Integrating the Code Guru profiler will allow you to deep dive into your application stack trace and identify inefficiencies. Alright, having seen the Code Guru profiler with issues, let's look at what it looks like after rectification. So this is a without issues demo, and as you can see now, the stack trace is a lot cleaner and I've got 0 recommendations. So that's the Code Guru demo. Let's jump back into my load test to see how that's going. So here I am back in the Lambda console. Let me refresh my Lambda console to see the invocations. The invocations are still not showing up in Lambda. Let's see what my test is saying. And my test is saying that it's complete. What you can see here is that I get an overview or a collated view of the average response time, average latency, and average connection time. This means that I can very succinctly determine how effective my endpoints were. If I go back into Lambda and increase my window, as you can see, I now have a metric of how many invocations was happening. So in this case, my Lambda had 75.9K concurrent invocations. That was the traffic being thrown at by my load test. Alright, so that's it for the distributed load testing demo and the Amazon Code Guru profiler demo. Let's jump back into the presentation. Alright, so we just saw a demo of Amazon Code Guru profiler and the distributed load testing solution built by the Amazon Solutions Lab. Now let's summarize what we learned in the session today. We looked at the journey of a line of code from a developer's laptop straight through to production. We looked at how in local dev and test, we can emulate cloud services locally. How in integration and test, we can use Amazon Code Build to build and test our code. And finally, in deploy and test, we look at how we can load test our applications, as well as how we can constantly monitor them to Amazon Code Guru. That's it for the session today, everyone. Hope you really enjoyed it, and please do leave a review. We really value your feedback. Thank you.